tackle adding and subtracting rational expressions. I'm going to start with two examples. The first being a normal fraction. I'll remind you how we add fractions. The second is more of the flavor this video is focused on, adding two rational expressions. In this first example, I'm adding 3/7 and 5/14. The important thing with fractions is when I want to add or subtract them, what I need to do is find a common denominator, and then I interact the numerators together. In this case right here, what I can do is multiply the numerator and denominator of this fraction by 2. What that does is it creates the common denominator of 14. So it becomes 6/14 plus 5/14. As soon as I have a common denominator, then when I interact the numerators, so I do 6 plus 5 in the numerator, and I keep that shared denominator right there. Adding rational expressions is exactly the same. The trick is we have polynomial expressions in the denominator. So when we multiply, we need to realize polynomial multiplication is coming into play. It's important to note that when I'm working with rational expressions, I do exactly the same things I do with any kind of fractional expressions. Again, the difference is the numerator and denominator will have expressions that are polynomials. So in this case, if I multiply a fraction by a number in the numerator and denominator, or by an expression, I need to realize polynomial multiplications in play. In this case, what I'm going to do for my first step is I'm going to multiply the numerator and denominator by 2. Again, in this example, when I multiply the numerator and denominator by 2, because they have more than one term, I need to make sure I use distribution when I multiply this out. The numerator would give me a 2x plus 10. And the reason I multiply by 2 is because the denominator becomes 2x plus 6, which is now the same as this second expression. Once I have my shared common denominator again, I add the numerators. I'm adding polynomial expressions. I need to make sure I combine like terms. In this case, 2x plus 3x is 5x. 10 plus 5 is 15. All over my shared denominator of 2x plus 6. Now what I need to always do is after I've added these together, I need to check to see if I can reduce this further. I do that by factoring. In the numerator, I'm going to factor out the greatest common factor of 5. I'm going to factor out the greatest common factor of 2 in the denominator. And lo and behold, I do have a shared common factor of x plus 3. This simplifies down into 5/2. Let's now look at two more examples. The important thing to remember is I do exactly the same thing with normal fractions with numbers that I do with rational expressions, though I'm going to have polynomials in the numerators and denominators, so the actual act of multiplying and adding will feel a little bit different. All right, in this example, I have a little bit more complicated denominators. If I'm going to add these, I know I need to find a common denominator. What I'm going to do is multiply this second fraction here by an expression to make this denominator turn into x squared plus 3x minus 28. This should feel like a pretty crazy difficult thing to do. You're like, well, what the heck could I multiply this expression by so that I result in this quadratic right here? Though there's an easy way to attack this. What you do is first factor this denominator right here. Factoring a quadratic or factoring any polynomial is to write it as multiplication. So what I'm going to do is I'm going to rewrite this factors, by the way, into x plus 7 times x minus 4. What this is telling me is that if I take x minus 4 and I multiply it by x plus 7, I get x squared plus 3x minus 28. That's my expression that I want to multiply. In this second fraction, I'm going to multiply the numerator and denominator by x plus 7. So what I now have is x plus 8 over this common denominator now of x squared plus 3x minus 28. Over here in the numerator, I need to make sure I distribute the 9 to the x and the 7 to get 9x plus 63 all over x squared plus 3x minus 28. If you've gotten this far, you're noticing a trend with rational expressions. Rational expressions, when we're attacking them, we're almost always going to factor any polynomial we see. That's because of the fundamental principle of fractions relates equivalent of fractions based on multiplication. Writing this in factored form, again, is showing me what things multiply together to be x squared plus 3x minus 28 in this case. I don't have to actually FOIL this and do the multiplication. I did the work in this half over here. Now that I have a shared denominator, I'm simply going to add the numerators together. X plus 9x is 10x. 8 plus 36 plus 63, is 71, all over my shared denominator of x squared plus 3x minus 28. Now what I would do is, again, see if I can simplify this. I don't see any way of factoring this numerator. Before we move to our last example, I want to point out that I could have written the factored form of this denominator here instead of written it in its expanded form. That would have been useful in this last step when it came to simplify, but there is no simplifying to do. This is my final answer. In this last example, we're subtracting two rational expressions, which really is exactly the same as adding them, with the small caveat that I'm subtracting, and I need to show you how to deal with the second numerator here. My first step is to figure out what I need to multiply to make these the same. I'm going to factor these denominators. There's no factoring to do here. This is a difference of squares. This factors into x plus 6 times x minus 6. This is a good place for another hint. When I'm looking to factor these denominators, I'm expecting, if this problem was developed to work in a useful way, that if this factors, one of those factors is this denominator right here, you can use that to quickly factor these denominators. What I know now is that x squared minus 36 is x plus 6 times x minus 6, meaning if I multiply this fraction of the numerator and denominator by x minus 6, this will give me my shared denominator. What I'm going to do now is multiply the numerator. Important, these are two binomials. I need to FOIL this out. When I multiply this out, I'll get x squared minus 11x plus 30. In the denominator, I'm not actually going to multiply them out this time. I'm just going to write it as x minus 6 times x plus 6. Nothing happens over here in this second fraction. All right, now this is the only difference between addition and subtraction, really, is I need to make sure that when I'm subtracting this expression, I'm subtracting both the 3x and the negative 7. What I can do is write it like this. Instead of actually doing the act of subtracting them, I'm just going to write them all together on one fraction. I'm going to say minus 3x minus 7 like this. I write it like that so that I remind myself to subtract both the 3x and the negative 7. Now, I just need to make sure that I distribute this negative to both of these terms before I combine like terms. Then it becomes a negative 3x and a positive 7. Now I can combine like terms to get x squared minus 14x plus 37 all over x minus 6 times x plus 6. Again, what I would need to make sure that I do is to see if I can factor the numerator to see if I can cancel any common factors. This does not factor in any useful way. That is my final answer.